Another problem that we're going to come across are mixture problems, where we combined one solution with a higher degree solution to produce what we want. So imagine I have a 10% solution and a 60% solution in my warehouse, but I need to dilute them to produce a 30% solution. So in this particular equation, so how much do I put in of the 10%, how much of the 60%, so that I get, in this case, 50 milliliters of 30% solution. Well, once you take that in, we start to build, or can build, a little bit of a system here to solve. Ask you first of all, how much of this one? We don't know, so let's label that an X. How much of this one? Let's label that a Y. So I already see one equation right away. X plus Y equals 50 milliliters. This amount plus this amount has to equal 50. There's one equation. Now where's the next one at? Well, the next one is based on the solution of each of these. This is a 10% solution of this amount. So that becomes 10% or 0.10 of X plus 0.60 of Y equals 0.30 of that amount, which is 50. So 10% of X plus 60% of Y equals 30% of 50, the total. There's my two equations. I'll write them out over here. X plus Y equals 50, and 0.1X plus 0.6Y equals 30 times 50. Yeah. 15. We have a system. Now we can go ahead and scale the system so a variable could drop out. Let's multiply the bottom one by 10 first of all. And then we can just multiply top or bottom by a -1. And I'll do the top one. So in this first one, I multiplied by a 10. The second one, I'm going to multiply by a -1 through. And that produces a negative X minus a Y equals a -50. X plus 6Y equals 150. Still maintaining my system so I don't get lost in my work. Adding them, the X's are eliminated. And it looks like for this to work, I need to have 20 milliliters of my 60% solution. And then how much of my X% solution? Well, X plus 20 equals 50. That looks like that's going to be 30 milliliters of the first solution. And so there's another way that we can start to look at systems in order to solve, in this particular case, mixture problems.